In this video, we're going to prepare the data for training unit for nuclei segmentation. So if we go back to the folder downloaded from GitHub, in the data, we have a folder which is entitled Annotated Nuclei. So if we just have a look at this, so we have 5 images, and each of them is only one channel, which is the DAPI we're going to use to segment nuclei. If I open the corresponding mask, it looks like this. So here you have a different intensity for each nucleus. We can actually look at it with Annotator. If I go into plugin Annotator, if I open, so it's going to be in data. So let's go back here, data, annotated nuclei. If I open this image, and I open corresponding mask in here. So now I can have a look at all the different nuclei, as you can see. The thing is, so that's very useful for instance segmentation, but here we use unit, and with unit we do semantic segmentation. So let's just close this and go back to the mask we have. Clearly we cannot use this directly with unit because here we have a different intensity for each individual nucleus, but with unit we're gonna estimate a class at each pixel and not doing instance segmentation like we have here. So one thing we can do, as separating nuclei is really a tough task. As you can see, we have a very high density of touching nuclei. So we can use 3 different classes, one for background, one for nuclei inside nuclei, and one for nuclei contours. So that's what we're gonna do. So first of all, I'm gonna copy the images we have in annotated nuclei in the training, so in the data sets we have in unit, because this we're going to use it. So I'm going to open another explorer like this, and I'm going to go, if I go back, deep learning, codes, unit, data sets. So here I have a nuclei folder, so I'm going to open it. So in test, we have the images we want to process, so we'll do that when we have trained a classifier. But here I'm going to have a training. So I'm going to create a folder that I'm going to call training. And in training, I'm going to copy the images we have in the data folder, in folder we downloaded from GitHub. So I'm just going to copy and paste. So I already have the images. Now I'm going to create a folder that I'm going to call masks. And the goal now is to convert the images we have here for the annotation, where we have a different intensity for each individual nucleus, to images where we will have 3 different classes, one for background, one for inner nuclei, and one for nuclei contours. And that's something I can do with a pre-processing notebook. So let me go back to my notebook, which are here, sorry. And so here I'm in unit, and I'm going to open the pre-processing notebook, which is called pre-processing convert nuclei mask into nuclei contours background. That's what we have. We have individual nuclei, and we want to convert them into the 3 classes. So if I open it, so it's still organized the same way. So I'm going to first load the codes and Python packages. Then I'm going to run the parameter panel, only 2 parameters, one for the input mask. So that's where the mask, so the images with different intensity for each nucleus are. So I'm going to select it. So here, by default, I'm in datasets in unit, but I want to go to data. So maybe you're not familiar with it, but when you have 2 dots like this, it means to go to the parent directory. So I'm going to go up, and here I'm in unit, so I need to go up again and here I'm in code, so I need to go up one last time. And now you see we have a data directory, so I'm going to go in data directory, I'm going to go in annotated nuclei, and I'm going to select the mask. And that's the images I want to convert. So I'm going to select this folder. The output is the one I just defined, which is in datasets, in nuclei, and in training and in mask. I'm going to select it. So now that my parameters are defined, I'm going to run this Python function, which just actually converts so individual nuclei to classes. So it's not very long, but it's not instantaneous. So here again, if you look at it, it's running. I have a star here, it's running. I have the icon here, but I can go back to so that's annotated, that's not the one training, and you see two images were already processed. So let's open this one. If you remember, that's the same, and now we should have the corresponding mask. But as you can see here, so we have two different classes. First one is the contours, second one is the nuclei. And actually, when you train UNet with the codes that are implemented in there, if you say that you have three classes and you give a mask with only two stacks, the algorithm will know that every single pixel that is not labeled in the first stack, in the first image, or in the second, is automatically the third. So here, all the pixels that are black in there and black in there are actually part of the background. Let's just zoom in and you'll see something else. If I go back to the contours here, it's pretty clear. When you have isolated nuclei, I'm going to even zoom in a little bit more. The width is just 1 pixel. So the contour is just 1 pixel width. However, when we have touching nuclei, we have contour which is 2 pixel width. So that is done on purpose. And you see here, so the contours are thicker in this area than when we have isolated nuclei. This is done on purpose because we know that probably the most difficult part is to separate nuclei. And just to give more chances to the algorithm, we have contours that are thicker when nuclei are touching in order to have a UNet classifier that's going to be more trained to separate, to identify the contours. So now everything is down. If I look at my folder here, I have 5 images in the mask. So we're going to do the same way we did it for epithelium and stroma segmentation. We're going to define a training and a validation. So I'm going to use those two again. I'm going to go back here in deep learning and codes and UNet datasets, nuclei. I'm going to create a new folder that I'm going to entitle validation. All right. And in validation, I'm going to define 2 folders, one for images, and that's so given the codes we have, that's something that always has to be done. We need folders with images and mask, and same name for images and mask in those folders, so the algorithm can pair the annotated images to the images. And I'm just going to put one image in the validation because we don't have that many images. So if you look at this images, the last one is actually smaller. It's just as same height but half the width. So we're going to put this one in the validation. So if I go to mask here, I'm going to move the mask, so from training to validation, and same thing in images. So here I'm going to go up in images, take the last one, and so now I have 4 images in the training data set in both images and mask, and they are corresponding names. And if I go to validation, I have 1 in image and 1 in mask, and the same one. And so now we are ready to train a UNet for nuclei segmentation.